they've got a great line of volunteers that have always been incredibly helpful. So shout out to those guys. Before we get started in our talk, I want to highlight in Tulsa, I think it's on June 4th, I believe, so it's coming up pretty quick. There's the 200 OK conference, and if you go to that website, you can see the speaker list. I think it's more of like a web-centric conference, but it's local, and it's going to be a lot of great speakers lined up. They got a promo code. As of this morning, I think they had like 17 tickets left. So if you're interested in going to that and would like $25 off, use that promo code. And if you forget what that is, you can come and find me afterwards and I'll tell you. All right. I'm giving the talk today. My name is Jordan Parmer, and I am a software engineer at Augsburg. And we've been doing this group now for probably, I think it's been about 8 to 10 months, and we've had a wide range of talks. Some have been about languages, some have been about category theory, and I had a lot of people come up to me and say, hey, we'd like kind of another like intro talk that puts some of the category theory stuff that you guys have been talking about into a really simple real-world application. And so that's something I'd like to do today. And if you are not able to use a functional language yet, so maybe you're working at a place where you're doing a lot of like C# or Java, and you haven't been able to like move over to a functional language, maybe because of your team or just the thing that you use. One thing I'd like to do today is to see if we can kind of maybe encourage or entice, show some options on how you might be able to do that, or why you might want to be able to do that or not. So we'll talk about that some today as well. Now, before I get started, it was this weekend and I was working on this talk, and my kids were kind of wondering like what I was getting ready for, and I was trying to explain to them, oh, I'm giving this talk at this user group, and we got these people come and we talk about functional programming and category theory. They didn't really understand what that meant. So I thought I'd say, okay, tell you what, if you guys would go draw a picture of what you think a functor or a monad is, I would put it up as the first slide, okay? So my son, my oldest son, took this challenge, and this is what he came up with. I instantly fell in love with that. So that is, in my opinion, the best definition of a monoid and a functor that I've seen, or monad. So anyway, yeah, so shout out to Luke, Ellie, Levi, and Jude if you're watching. So I might just stop after that. That's my favorite part. Okay. So moving on. So today's goal is what we're going to do is we're going to build a really simple yet fairly real-world application using purely functional techniques. And the idea is to compare some of the things that we might do or be stuck with in an object-oriented or imperative language, and then how that might look in a functional way. And I'm also curious kind of throughout this to get feedback from you guys as well. So if you see something that you'd like to give input to, feel free to call it out or say it. That's fine. I'm going to try to keep it fairly intro friendly, but we'll kind of move into some more intermediate stuff as we get through, and we'll just kind of see what time allows here. In particular, what we're going to focus on is control flow and error states, because that is a very compelling reason to get into functional programming for starts. Because functional programming really helps you reduce a lot of noise in your code, and then also is a very concise, like provable way of writing an application, very clean. And so this is some of the things that I think are a really good intro into why you would want to go there. Now, I have most of my experience in Scala. I really like Scala as a language. But at the same time, I didn't want what I show today to be too biased towards that language. So everything I'm going to show today, even though it's in Scala as a language, it is available in all of the primary, or say, like, most popular functional languages out there. So F#, Haskell, Elm, and others, all of these concepts are directly transferable to those, and more or less the names are the same too. Okay, so don't let the fact that this is in Scala, discourage you. Now, if you are in C#, Java, JavaScript, you are not far off from having a functional language that's an equivalent to those in place. And that's one thing I really want to call out. So if you work with a team that's in .NET, and let's say you guys are very heavily invested in C#, but you've always been curious about F#, this is one thing that would be kind of nice, is to say this is why it might be compelling to give it a shot. Same thing with Java. There's a lot of options in Java. There's Scala, Clojure, a newer one, EDA, I don't know how they say that. There's also Kotlin. So a lot of interesting options there. ETA or EDA, that one, for those of you who are curious, is like Haskell on the JVM, so that's pretty sweet. It's a new one. Also, if you're in JavaScript, some people say, well, JavaScript supports some functional stuff, but there's more pure languages out there, such as PureScript and Elm. So anyway, I encourage you to look at those, and if you got a team that is heavily invested in one of the imperative languages, you might want to take a look at the functional equivalent to kind of see the benefits that you might get, and it still will work with all of your other codes. You don't have to throw everything out and rewrite. Okay, so first things first. When we start talking about functional programming, one of the things that immediately comes up are these words and these terms. And I believe that these are kind of the high-level words that you should start getting comfortable with when you get into functional programming. Now, if you understand what a monoid is, a functor, a monad, that will go a long way into improving your ability to write successful functional code, very pure functional code. Now, the flip side to this is that they're kind of intimidating words because they're brand new, they're very mathematical in nature, they come from category theory, and a lot of times when you start throwing that around, it immediately becomes less attractive or intimidating, and I totally get that. There are blog posts out there, and I know certain websites, in fact there's a guy I'm going to quote today who writes a lot about FP, but on his website, he makes the point, he goes, I don't want to see anybody use the M word, we're not going to talk about monads, we're not going to talk about applicatives, those aren't friendly words, so we're going to stay away from them, anybody that even uses them are going to be banned from my site. I do not think that's the right approach, and the reason is that you should call things for what they are. If we're going to talk about a monad, that brings along very important context, and you should understand what that means. So I can talk to anybody else that does FP about, I'm using a monad here, and that carries certain meaning along with it. And Zach did our presentation last month. I thought one of the greatest things Zach said was, I was trying to Google around for this technique, and I was having a really hard time, and part of it is just knowing the words to Google with. And if you know what a monad is and you're trying to look up stuff, then you're going to find it by that, not by some other derivative name that is kind of fluffed and made up by a particular blog author. So I encourage you not to be intimidated by these words. If you're coming from, like, let's say that you first learn procedural programming and you move into object-oriented programming, you got to go through the same thing. You got to suddenly know what encapsulation means. What does polymorphism mean? What's a singleton? You're not worried about that when you're writing C code. Same thing, when you're in JavaScript, you understand what a prototype language is and what prototypes are. You understand a lot about like hash tables and how JavaScript works. You move into another paradigm, you got to understand what the words are there. So same thing when we get into functional programming. There's a lot of terminology, and you shouldn't just turn it away because it's intimidating or it comes too much from like a mathematical background. In fact, as you get deeper into it, you realize these are really cool things and they're really great. So I just want to kind of throw that out there before we dive in. I am going to try to use those terms, but I'm going to try to demonstrate how they work with code, okay? Okay, so before we dive into code, I want to talk about one pattern, which I think is a very compelling pattern, and that is what Scott Lashlin, I'm not going to say that name right, coined as the railway pattern, okay? And this is a very interesting pattern for handling control flow. So in this example, we have three operations that we're going to perform on data. So we have, let's say we've got a source on the far left there, and a source is going to produce some sort of collection or sequence of data items, all right? And we're going to do three things to those. We're going to do a parse, a transform, and then we're going to send it somewhere else. Maybe we send it to a database or a message queue. And there are two clear paths that are going to happen. There's a success path and there's a failure path. Now we do this no matter what paradigm you're in. This is a very common thing that you need to do. But let's for a minute step back and try to abstract out that concept. All right, so You know, instead of looking at it in terms of how we implement it, let's just think about what each function has. Each function has two potential outputs. There's a success and then there's a failure, okay? Some people call it the happy path or the sad path. And we want to chain these operations together. So we want to do this first and then go over here and do this. And maybe the second thing uses the result from the first thing. Now, if it's successful from the first function, you want that to carry straight into the second function. But if there is an error in the first function, you want to bypass the second function, okay? So this is just very basic control flow. And same thing, if there is in the second function going to the third an error, then we want to be able to transition at that point to the failure path. So this is why they call it a railway. You can think about it in terms of two railways, one that is kind of representing the successful default railway path, and then you can have a transition or a switch at any point in time going down to the failure path. And so what we'd like to be able to do is, in the case of a failure, switch to or bypass all subsequent operations while still being able to compose them into a single chain. And it's that last bit I really want to focus on here. If we can come up with an abstraction that lets us compose functions together in a very nice terse package, but then in the case of an error, carry that along without kind of muddying up my code, that would be the ideal thing to do. Now, in an imperative language, we have all kinds of ways we can do that. You know, we can look at using if conditionals. So if this, then do this, if this, then do this. But we know that those aren't really tight because you can make a mistake in an if conditional. You can have an else statement that you forgot. It's not really tightly bound to the context of the problem, and there's all kinds of mistakes you can make. You could throw an exception. But if you throw an exception, you've now left the default call stack and you're reaching out somewhere else now. And so that's really still not controlling the flow of movement through a clean path through your code. So we'll talk about how we're going to address this. All right, so I'm going to try to live code a lot of this. I am not good at live coding. I'm a little nervous actually. So I have a cheat sheet and some backups. So we're gonna kind of see how this goes. I also do not type very well when people watch me. So this is going to be awesome, all right? But here we go. We're going to give this a pretty good shot here. Okay, so here's my Scala code, and I have a lot of stuff stubbed out, and I'm going to kind of walk through this real quick. The very first thing that I want to look at is this over here. Okay, so focus on this. What we have is we've got a raw data object with one function. It's going to generate a lot of these raw user types, all right? So a raw user is just going to represent some sort of user that we might have in our system. There's going to be a full name, so it's going to be first name space last name. It's going to be all in one string variable. We're going to have like an email address and a phone number, okay? And so all we're going to do is when we call this generate raw users, we're going to return a sequence of these things, all right? So that's kind of the input into this logic here, all right? So I'm going to shelve that over here. And now let's look at our raw user type, okay? So as I said, we have a case class. So this is how we're going to define a type in Scala. And it's going to have full name, an email, phone, and some other information, all right? Now what we want to do, ultimately, is transform this raw user into a domain type. So this raw user has very kind of just raw dirty code that we might get from somewhere, and we want to transform that into a really nice domain rich type. So that's going to be domain user, oops, down here, okay? So if we look at domain user, we have a person type and a phone number. For the sake of simplicity, we're just going to worry about extracting those two things, okay, because I didn't want to have a lot of other code. But let's just we're going to pull out a person type, which is going to be first name and last name separated out, and then we're going to have a phone number. And a phone number, if you look at its definition, is rich in that it's got a county code, area code, a prefix, and a line number separated out, okay? So what we want to do is produce a rich phone number object from that string, okay? So if we go to the top of our main function, this is kind of the unit of work here. We're going to call go, which is going to emit a sequence of these raw users. We're going to transform a raw user to a domain user, and then we're going to have some way of calculating the result of that. So what we're going to do is we're going to count the number of times that this is done successfully, and we're also going to tally up the number of times that this failed and didn't go well. All right? Any questions about just the boilerplate part here? Look good? Okay. So let's go down to the first part with the phone number. So let's look at this function first. A phone number, we're going to have a function that can take a raw string and break out the interesting bits. So I'm going to use a regex to do this, and it's going to be a very simple regular expression. It's going to be 1 digit dash 3 digits dash 3 digits dash 4 digits. That's all we're going to capture. So first things first, string to a phone number. What are some possible problems that might happen here? Sorry? It may not be a string, okay. May not be formatted the way I want. So I'm applying a regular expression. The string that I get might not match that expression, so I might have a problem, okay? Now, my function signature does not account for that right now, right? So I'm expecting a string, I'm returning a phone number, but I got to do something if that does not work well, okay? So let's go over here. I just want to talk Scala for a minute. And I say Scala, what I really mean is I want to talk about functional objects for a minute. So one type that we have at our disposal is called the option type. In some languages it's called maybe. And this is a pretty simple type. The idea of the option type is that you have a box, and there's either some value in there or not. It's empty, okay? And so there are usually subtypes to this. So you have some and none. So the sum subtype means you've got something, some value that's in the option, and the none subtype is if it's empty. Okay, so very, very basic. So let's create a couple of these. We're going to say this is going to be an option of an integer, and we're going to say, can you guys see that down here? See if I can, nope. Okay. Well, not getting any helps here. Okay, I'll try to bump that up. So let's put a 100 in there. Option int, and we're going to put none in here. Okay, so the first 01, I've created a sum of 100. So that means that inside of my box, there's a value of 100. And then in my option 2, I'm going to assign none. So essentially, there's nothing in there. So I can do some interesting things with this. I can say o1.get, which technically you should never do, and I'll show you why. So I can actually get the value out of that. If I do o2.get, I'm going to get an exception because there's nothing in there and I tried to fetch it. So I could do something like get or else, and I provide maybe like another number. All right. Now what's interesting about these is I can do some cool checks on this. So one thing I can do is pattern match. So I can say, all right, if O1 contains some value x, then we're going to add 100 to it. And if it doesn't contain a value, then we're going to like return 0. And what that does is that there's 100 in there. The pattern match found it, and then it said, okay, I'm going to add 100. Pattern matching in functional languages is incredibly rich because I can match on a lot more than just a predicate. I can actually match on types, which makes them incredibly powerful. I can say o2.match if I do the same thing. Oops, none, 0. And in this case, I'm going to get 0 because it matched the none case. Now, let's say I want to do something interesting with the contents of this, but still maintain the optional nature of my value. I can say o1.map. Now, one of the laws that an option allows is a functor law. And a functor is just a term of applying a transformation to a value. So I'm going from an A to a B. And I can get into more detail at the end of this if we have time. But essentially, in category theory, a functor matches one category to another. An endofunctor matches from one category to the same category. In programming languages, we're in the category of types. So what I'm doing is that I'm going to have a map which says, okay, if there's a value inside this box, we're going to apply this function to that value, and I'm going to get something out of it. All right, so I can say o1.map, and if there's for the value x that's in there, I'm going to add 100 and close my parenthesis. All right, so there we go. We have 200 that came out of that. Now let's say there's not anything in the option. So my O2, which is none, if I apply a map to that, it still returns none. There's nothing in there to apply the value for. But I didn't get like an exception, I didn't get any kind of error. I just got back the same none that I applied the function to. And I could chain these things. I could say, okay, .map, and once again, for x, we're going to subtract 100. And nothing happens because there's nothing in there. So I've now applied two functions in a chain, and it still worked with the option. And if I were to do the same thing to O1, then it's going to actually apply the logic in sequence to that, all right? I can do things like O1.filter, where x is greater than 50, and then I can map on it. So I can apply all kinds of really cool operations on these things. Let's look at something else that's neat. Now, some people might say, well, how is this different than just using like a null? Because you know, null represents like nothing. Well, it's because that this option type uses a lot of laws from category theory. So we just talked about how it represents the functor law. It also can represent a monoid law, which means I can add things together. So let's say I have another option. I can type, okay, we're going to put a value in there. So we have O1, which represents something. And what I can do is use this operator on, oh, you can't see that. Okay, I'm going to use that operator on my two options. And what it's done is it's taken two options and it said, okay, if both of those have something in them, then it's going to append them together. In this case, the append operation for an integer is an add. So it's going to create a brand new option that has the added value of that inside of it. But if in the mix I add a none, then I'm going to get the leftmost side that has something. So I've done O1, I've appended a none to it, so I'm going to get the O1. But if I were to flip that around, I get the same thing. I can't remember. Okay, I'm going to get the same thing. All right. So it doesn't matter what side it's on. But yes. Yeah, so for any Scala people in here, I'm leveraging a Scala Z operator. And Scala Z is a library that gives me more category theory type tools, very similar to Haskell. Okay, so pretty cool. And I can chain these together. So I can also do additional stuff where I add O3, and then I get all of those combined together, all right? Okay, so going back to our code, long way to get here. One option I could do is return an option of a phone number. Now, that gets us a little bit better because now I cannot throw an exception. I don't want to throw an exception. I don't like those. And I don't have to return null. You should never do that. But what am I losing in this particular case? Because it's still not like really great. So what happens if I get none out of this function? Correct. I don't have any context into knowing what happened. Now I could conventionally say, well, if you get a none, then that would mean this function couldn't parse it out. You could say that and just use that as a convention. But it would be kind of nice if I needed to get richer information from that. So there's another tool we can use called a disjunction. So let's go back to our code here. A disjunction is a way to represent two different states in the same type. And it's traditionally used to handle an error case or a success case. And there's a category theory law that actually explains how that all works. I'm not going to get into that right now. But typically, you'll see this in Scala. It's either an either type. So I might have the type like, well, I got this screen problem here. I might have either an error on what's called the left or a success that's on the right. And so a lot of these functions on it will be dot left or dot right, and that kind of conventionally means error or success. In Scala Z, you can use this operator, // which represents the state. Now the cool thing about a disjunction is that it follows the same laws as a monoid and a monad. That means all of the cool chaining I can do with a monoid monad, I can do to a disjunction, which means I can compose multiple operators together that yield a disjunction to kind of maintain this chain. Remember, we're trying to build a railway of success and error. So let's say I've got val v1. I'm going to say that is a success. Oh, let's do this. Okay, the way I denote a success case is I put a dash on either the right or the left. So a success would be a dash on the far right. So on the far right, I'm saying if it's a success, I'm going to return an integer. But if it's a failure, I'm going to return a string on the left. Okay, so there we have a right disjunction. And if I go v2, okay, so here I have v1 is a success, it's right, v2 is a failure, it's a left. So I can say v1, I can do the same thing, I can append these guys. If there's a failure in this case, in any position, it's going to return the failure. I can also do things where I say v1.map, and if it was a success, it's a right, it'll apply it, but if it's a left, it won't. Okay, so then if we do v2.map, okay, it's still going to return a fail. So a little bit better, because now we can encode error information into my call. So let's do that with this. So let's change this to be, let's go with a transform error. You can see the definition of that on the top, or a phone number. So what this type is saying is on the left, if it's an error, we're going to return that type. And if it's success, we're going to return that type, phone number, which is what we want. Okay? All right. Yes, you can use either as well. So if you're familiar with Scala, there's another type called the either type. It's built into the standard library. And yeah, the question there is if you're using a library like Scala Z, Scala Z comes with a lot of type classes that handle the monoid monad laws. And so a disjunction provides that type class for that type. And so you get all of the rich API stuff from that. So it's mainly if you're a Scala developer using Scala Z, you can benefit from all those type class stuff that they provide that isn't just with the standard either type. So that's the big difference. If you're just doing straight up Scala standard library, then stick with an either and you're good. The other thing is a disjunction is right biased. So if you're using a for comprehension, you don't have to say dot right at the end of everything. It just defaults to that. Okay, so let's see here. Okay, so what we're going to do is we're going to run this regex on the pattern. So we're going to say phone string match, and then we can say pattern, case pattern. And then the really cool thing about pattern matching is I can just do a case statement on the regex itself and then break it out. So we're going to have area, prefix, and what's called the line code. So if my pattern match is successful, those variables will be the grouped values from the regex. It'll be the captured groups, which is pretty sweet. I don't have to do any kind of funky API stuff to extract my groups out. If that fails, all right, let's handle that case first. So if there's anything other than a match, what we're going to do is we're going to return a left disjunction with a transform error, and we're going to say, The phone string didn't parse. If I was doing this for reals, I would give why it didn't parse, okay? So now we have our error state, and we'll return a disjunction from this. Now, this brings us to the next question. Okay, so we want to parse out the pieces of that phone number. Now, each of those are going to be strings, but my phone number type has them as integers. So I need to convert from a string to an integer. Well, this is also an opportunity for a problem, right? So if I were to say, okay, let's do phone number, and I were to do code.toInt, okay, so if you're familiar with Java, you can do toInt on a string. All right, so I could do code.toInt, area.toInt, prefix. I'm sorry? Oh, okay. Okay, I had that wrong then. All right, so if I were to do something like this, this would compile, it would run, but what's the problem I'm going to hit, potentially? Assuming my regex was off. Yeah, I got a string, maybe there was an alphanumeric, and it's going to bomb. So if I had my regex wrong, that would be a possibility, right? My regex is good, but that's not standard with me. So, so yeah, we could do this, and this would be valid code. But it has the potential of throwing an exception, and we don't like exceptions. So let's see if we can come up with some way to address this, okay? So let's write a function called toInteger that's going to take in a string, and once again, we're going to return a disjunction of the parsing result. So we're going to say transform error or an integer. Okay, now I'm going to drop some Scala that I really care to talk about real quick. So I'm just going to type this out and kind of bear with me. So I'm going to do a try s.toInt to disjunction dot left map transform error. Okay, so real quick, what this is going to do is try is a Scala type that's also a monad that will catch an exception but keep it into a monad state. We're going to convert that to a disjunction. That's just a built-in function. And then we're going to say if this thing is a left, then apply this map to it. So in other words, if we get a left out of that conversion, we're going to transform it into a transform error. Don't really worry about that, but that's kind of what's happening here. So what this allows us to do is say toInt code, and now I get my disjunction. Well, now I got another problem. My phone number constructor does not take disjunctions. It takes integers. And I really don't want to rewrite that thing to take disjunctions as its types, okay? Because now I'm kind of muddying my data types with the functional constructs, and that just doesn't really feel very clean. So I don't want to go down that path. So there's something else I'd like to be able to do here. This brings us to a concept called applicatives, which are pretty awesome. And how an applicative works is if you have something that follows applicative law, and what that means is that you have a valid apply function and a, oh, I'm missing the other one. It's apply and something else. I think it's just identity. Then I can apply a series of options to construct an object. So let's just take two options first. Let's say I have a class called foo, case class foo, and that has two integers. So you can't. Is it pure? Is that it? Okay, thank you. Okay, so let's say I have a class foo, and foo's constructor takes two integers. But let's say all I have are options of integer. Now, with an option, any of those might be none. So I don't really want to construct a foo if one of them are none. So what would be really nice is to try to construct a foo using the values inside of those options, but if any of them are none, then the whole construction also returns a none. Okay, you kind of see where we're going here? So if I had my O1, O2, do I have an O3? Did I create that? I did, okay. So I got my three options, let's say. And I have a couple of ways I can do this. Using standard Scala, I can use a for comprehension to build this. So I don't know if I really want to show that right now. What I want to do is show you the applicative form, so for the sake of time. So what that looks like is if I say O1, and then I'm going to use this operator in Scala, Z, O3, and then I'm going to use foo. Okay, look what happened here. What I said is O1, apply O3, and then what it's going to do is if that yields something, then we're going to have a sum of foo with the internal values applied to the constructor. All right? If I do the same thing with one of those that was the none case, so O2, I'm going to get a none out of that. So that's pretty cool. So now I can work purely with these options, and I can construct objects, and it either worked or it didn't, but that keeps me in my option context. So when I'm chaining stuff together, nothing's bringing me out of that context, which is really cool. The same thing works for disjunctions. I can use applicatives with disjunctions, and the neat thing is that for all of them that failed, I'm going to maintain that left side that has my specific error message, which is pretty neat. So I can say V1, that's the applicative I created earlier. V2, yeah, that was the same types. So because V2 is a fail, then I still get the left disjunction with the fail. And then if I use V3, which I think I created with a successful value, no, I didn't. Let's do that real quick. There we go. Okay, then we get a write with the constructed foo successfully. So going back to my code here, what I could do is just use applicatives. So I can say to int code. This is sometimes called the Macaulay-Culkin operator or the scream operator for those of you who are interested. Prefix. Then that's going to map to phone number. Oh, thank you. All right, see what we've done there? So now what we've done is each of those have the potential of returning a left. So we're just going to chain all that together, and then we're going to run the applicative. And so if anything's left, it's going to return a left in general. And then if they're all right, then it will construct the phone number successfully. So pretty cool. Any questions about that? Make sense? Okay. So let's go down to this case. So let's look at this person. If you look over at our raw data sets, one of the problems that we had was that the first name, last name was just in one string and it has a space in between. And let's say we want to parse those out into first name, last name separately. And we'll assume for the case of this example, they're all in the same format. We're not using like non-American names or middle names or anything. So what we can do here is we can say, oh wait, I got this wrong. I want to do it down here. There we go. This guy. So we can say, okay, person, again, we want to capture the case where this doesn't work. So let's do our transform error as a disjunction of person. And then we will say full name dot split. We'll split it on the space. And again, we can use pattern matching to pop these out. So we can say case first, last, nil. And then if that's the case, we'll return a right disjunction of a person with first and last. And in the case where that didn't work so well, we'll return a left disjunction with our transform error. Oops. Okay. So what this is using is pattern matching, and pattern matching also lets me extract the head of a list of a sequence of things. So I can keep dropping items using this cons operator, and as long as I keep going until I've hit nil, it will try to extract out those values. So if my pattern matched truly two things with a space in between, this first case will work, in which case I'll return a right disjunction. If for any reason that pattern didn't match and it went somewhere else, like let's say I had 3 things in the list or there wasn't a space, then we're going to get the left side, all right? So again, another kind of cool way of keeping this all disjunctions. All right, which brings us to our transform function. So let's kind of pluck this guy out up here. I'm just now realizing we are not going to finish this, but that's okay. Let's get a few interesting things. Okay. So now I have enough to convert a raw user to a domain user. So what that's going to look like is, first of all, I don't want to return a plain domain user. We're going to go ahead and keep the disjunction going all the way up. All right? And then we're going to say maybe person is going to be either a transform error or a person. And then maybe phone. It's going to be the same thing. And then we're going to just go back to our applicative here, because those are cool. Oops. Can't type with people watching. All right, and that's all I need to do. So now I have parsed out multiple things. All of them could throw a number of different problems, and the code is incredibly tight. All I can do is just say, I'm either going to have an error or it's going to be this thing, and I just say, look, here's the expression, try to build it. If it can build it, then it will, and it's going to return a disjunction coming out, and then if there's a failure, then it's just going to take the left route. But I can nest that code, all kinds of deep, and it's going to percolate that error up without having to throw exceptions and get off of the default call stack. So very nice and easy to read. Let's see, what else would be neat here? Let's go raw data, generate. Yes, okay. I think I have time for one other thing that I want to show before we run out of time here. And that is the concept of currying, which is pretty helpful. So taking this function, one of the things that I want to do is create, actually let's go up here. In my main, which I haven't been able to build yet, one of the things that I want to do is have this go function. And go is going to take a function as its input. It's called a higher order function. It's going to take a function as its input, and that function, when I call it, means that I have no inputs, but it is going to yield a sequence of these raw users. Now, what I'd like to do is hook it up to this guy, right? So I can call generate raw users, which doesn't take any inputs, and it yields a sequence of raw user. But let's say that in order to do that, I might want to read some values from a config file. A very common thing to do. You might have some sort of conditionals in your config file that will contribute to how it reads it. Let's say that you're going to connect to a database, and the database connection string is in the config file, and then that thing's going to run a query and pull data out. Well, those details I really don't want in my main code here. So if you're coming from an object-oriented world, you go, oh, that's easy, you can use dependency injection. And then you bring in Spring, and then your whole life is maintaining Spring code because that's what it requires, all right? Functional languages are nice because we're going to take that whole concept of dependency injection down to the most simplistic case at the function level. So we don't do dependency injection, well, you can with types, but you can also do it using a technique called currying. Now, currying doesn't exist for the case of dependency injection purely. Like there's actually a reason you curry, like in languages like Haskell, the only thing you do is curry, but it's a really nice benefit with it. So what currying allows us to do is partially apply parameters to a function. So let's say I have a function, we'll call it foobar, and that's going to take an int. Now I'm going to do, the way you do this in Scala is different than Haskell, for instance. In Scala, you have a parameter list with multiple parameter lists, a function with multiple parameter lists, that's what I was going for. So let's say that we're going to take 2 integers, and I'm going to say return x plus y. What I can do in Scala is I can say well, let's just do applying 1. If I call foobar and I pass in 1 integer, then what I get back is a function that's still expecting 1 more integer, all right? Because I've only applied 1 of the inputs. And then I'm going to get back really a function that I can call to pass in the other inputs that'll give me the final result. So if I want to fully apply it, I can say foobar 10, 20, all right? That gives me 30. But what's really nice is I can do this in a lazy manner. So it might make sense that I have one part of my code where I want to apply the partially applied function, but then later in my code, I want to invoke the rest of the parameters. This is where the real benefit of currying comes in. So I can say f1 is foobar 10, and what I've done is in the value of f1, I have placed the partially applied function, and so what essentially I've applied is a function into val f1, and then later I can do some stuff and I can call f1 with the other value. All right, pretty cool. So I can do this in the case where I have a config. So let's say I have this source object, and what I'd like to do is say, okay, I need to take in a config value, and then I'm going to partially apply this. So I'm going to curry here, and this is going to return a function that takes no input, and then it's going to yield a raw user. So what I could do is, well, I didn't really provide it, but I could say do something cool with config. Maybe I'm going to pluck out some values, some database connection strings, whatever. And then I can call raw data.generate raw users. So up here in my main, I could do okay. So the way I could start this whole thing out is I can say at the very beginning where I have access to my config class, I can pass that into source, and this is going to partially apply the config to that function, and then it's going to return me the remainder of that function, which is just a function that takes no inputs and yields a sequence raw user. So that can be the thing that I pass downstream, where I don't want my downstream code to know what a config is. I don't really care about that at that context, okay? Okay, well those are the things. I had some other stuff I wanted to show, but I'm kind of running short on time, so I think I'm going to call it there. I think I'm going to do some of the more category theory stuff for a part 2. Are there any questions about what you saw there? Anybody have any questions? Ah, right. That's a good question. So the question was, why did I use an applicative instead of a for comprehension? And that is a good question. I did not show for comprehensions in this, but what I could have done in my code, let's say I still have, okay, so I still got my options here, right? What you could do is use what's called a for comprehension. This might look different in some of the languages, but in Scala, this is the way it looks. I could say the value 1 being 01, and I could say the value of 2 is 03, and I could say yield a foo, which is v1, v2. Okay, that achieved the same thing as the applicative. And so what happens in a for comprehension is every item here essentially strips away the monad and gives me the inner value. So what I've done is in v1, if there is something in the monad, some value, that will get assigned to v1. And then as long as that chain is all of the same type of monad, then I can keep stripping away those layers. And then I have a yield where I can yield some sort of expression. And that could even be a code block right there. So yes, that's a totally valid way of representing that. I would maybe use a for comprehension if I had a little bit more complex logic to construct it. But the applicative is just a very nice terse way of doing the same thing. And so that's why I chose applicatives, because it's very small and terse. And I didn't need a lot of custom logic in the yield expression. Yes. Okay, so the question was, what happens in the none case? So let's do the same thing using my none. So remember, O1 had some, and then I think it was O2 had none in it. So what this is going to do is yield a none. So if any point along that chain I get a none, then it's going to do the same, it's going to fail. So this is the exact same thing as writing O1, O2, foo. For comprehensions, I should say, I can do some, we didn't get into monad law, which I would have liked to, but monads have the ability to flatten. And so if I have, monads are monoids that have monoids within inside of them. And so you can kind of get like these deeply nested monoids. And then you can do a flat map, which allows you to do the same logic, but flattens it all to the final top case. And so a for comprehension gives you a few more tools to work with more monadic types. And I'll probably save that for another talk in terms of what that looks like. Okay, any other questions? All right, cool, thanks guys. So moving on from that, just a few announcements. Don't forget about the OK200 if you're interested in going to that conference. Next month is Lightning Talks. I don't have any speakers for Lightning Talks yet. So if you're interested in giving a more abbreviated talk on a functional subject or technology or whatever, please come and find me. You can either find me on Twitter here, or I'm on Slack as well, or you can go to the OKCFP meetup page and there's a discussion board that you can drop your interest there. I might do part 2 and you'll have to hear me again if nobody speaks up. So just keep that in mind. All right, well, thanks for coming. I'm glad the pizza made it this time. You guys have a good one.